In this video, we'll see derivation of bending stress or flexural formula. So as you can see, the beam is simply supported at these two ends and it is subjected to the bending moment M. Now, because of this particular bending moment, what will happen to the beam that is shown over here? So you can see that because of the action of this bending moment, there will be deformation of the beam in such a way that a C layer, the top layer is in compression. So you can see this is the layer which has not changed in its length. The layer above this particular layer, they are all in compression, whereas the layer below the neutral layer, they are in tension. So we can say that in case of simply supported beam, the layers which are above the neutral layer, they are in compression. So these are all the layers which are over here. This is in compression. The layer below it is also in compression. Whereas the layer below this neutral layer over here, they will be in tension. Now you can see AC is shown and it is in compression, whereas BD is in tension. Now draw a line parallel to this AB. So that is C dash D dash that will pass through the neutral axis at point F. So EF is the small elementary length on the neutral axis. Now consider any layer GH at a distance y from the neutral axis. Now GH is the layer. Because of the bending moment M, its deformation is HK. So in this particular small triangle, the angle that is subtended, if this angle is delta theta, then this angle is also delta theta. So that is shown over here. Now using these values, so consider any layer GH whose deformation is HK because of the bending moment at a distance y from the neutral axis. R is the radius of curvature, O is the center point from which the radius of curvature is measured. So you can say that this particular angle, if this angle is delta theta, then this angle will also be, small angle will also be delta theta. Neutral layer is the layer which is neither in tension nor in compression. So as you can see, just now we have seen that just now we have seen that delta L, that is deformation of layer GH, is HK, that we have seen over here. Now HK is nothing but a very small arc, that is radius into theta. So radius is nothing but this distance FH, that is nothing but y, and angle is nothing but delta theta. So it is y into delta theta or d theta. Then we can say that GH is the layer located at a distance y from the neutral axis. Now suppose E is the longitudinal strain, then that is equal to deformation or change in length divided by original length. Substitute the value of delta L, that is y into d theta, whereas value of L is nothing but EF. So EF is this particular layer at the neutral axis or neutral layer. So this EF is nothing but R into delta theta or theta. So you can cancel out this delta theta or d theta. So we'll get that E is equal to y upon R. Now this is the value of longitudinal strain, but we know that according to Hooke's law, stress is directly proportional to strain. So substitute the value of E, that is y upon R. Now you can transfer this y on the other side. So we can say that sigma upon y is equal to E by R, or keep this equation 1 as it is. Now force is nothing but stress into area, 0. Now substitute the value of sigma from equation 1. So that is nothing but Ey upon R. We have taken sigma is equal to sigma x, that is forces in x direction, and then we have substituted the value of sigma, that is Ey upon R. Now E upon R is a constant, so in the integration it will be y dA is equal to 0. Now this particular value, integration of y dA, we have seen that in physics it is nothing but a y bar, and that is equal to 0. Now all these terms are constant. E is constant, R is constant, and A is constant. So ultimately we can say that y bar is equal to 0. Y bar is equal to 0 indicates that So once again try to understand. A y bar is the total moment of area because it is area multiplied by perpendicular distance. In this highlighted part, we can say that E is constant, that is modulus of elasticity. The radius of curvature is also constant. Area of the element is also constant. So if all these terms they are constant, ultimately y bar has to be equal to 0 because right hand side is 0. Y bar is equal to 0 indicates that this distance y is 0. Y will be 0 when we can say that GH is coinciding with EF. In other words, we can say that it is neutral axis itself or neutral layer itself, and this particular axis is nothing but our centroidal axis also, so we can say that neutral axis is the centroidal axis. Now by default that axis is taken as always the x-axis axis, that is deformation that we are taking is about x-axis axis. Now we know that moment is nothing but force into perpendicular distance, and force is nothing but stress into area. Substitute the value of stress, that is E upon R into Y, multiplied by dA or delta A, that is the small elementary area of the integration. Now this is nothing but E upon R is constant, so it is Y square dA. Now this is nothing but the definition of moment of inertia, that is summation of A into Y square is moment of inertia about X axis. So we can say that the another equation, second equation that we are getting is M is equal to E upon R into I, where I is integration of y square dA or summation of y square dA. Integration stands for summation also. So I is the moment of inertia about neutral axis. Now from equation 1, we have seen that sigma is equal to E into y upon R, or sigma upon y is equal to E upon R. Whereas from this second equation, M upon I is equal to E upon R. So from equation 2, M upon I will be equal to E upon R. Now right hand side of both this equation is same, so we can say that ultimately what we will have over here, you can equate all these three terms, that is sigma upon y is equal to M upon I is equal to E upon R. So this is known as what, the bending stress formula or flexural formula. So in this way you can derive this expression with the help of simple geometry and then concept of stress and strain. Thank you very much for watching. So here sigma is stress, y is the distance from the neutral axis, m is the maximum bending moment, I is the moment of inertia about x-axis or neutral axis. By default neutral axis is x-axis, E is the modulus of elasticity, and R is the radius of curvature. Thank you very much for watching.